Hello everyone out there and welcome to the Python training. So we are trying to have a look on the numbers. And you might be thinking what's so special about the number 0 to 9 and that's it. But that's not the case with the Python. Numbers can get immensely powerful in the Python and that's one of the reasons why it's been using quite a lot with the R. But in case you didn't got me what's that R, just leave that about. It was for the advanced users who are quite into the data analytics. Now let's come back onto the topic. So first of all, as usual, we'll have a /usr bin and Python. And the reason why I type it again and again, yes, of course, I could have created a new file. That's what I'm doing always in the movies. I could have written this one line, but my goal behind writing this line again and again is to make sure that how important it is you get that part. Now coming back onto the numbers, creating a number is really simple. Let's say I want to have a number and I simply say the account ID. Again, it could be anything. Let's say 1233. That's the account ID. That's it. And that's what it is. If I want to have a balance, I can simply call my balance as, let's say, with the precision, $33.45. And that's it. So this is all about the numbers. Numbers are data type which stores the numeric value. They are immutable data types, means that changing the value of the number data type result in a newly allocated object, as simple as it sounds. And it should be. Now numbers are quite a type in the Python. It can be integer, it can be long, that means long integer, it can be floating, and it can be complex numbers as well. Now for those who missed out a math class in your university or maybe at your high school, the complex number are also there in the Python, which are in the form of square root of -1. Don't worry, I will not go much into the depth of the complex number class. It's not at all a math class out there. But it's good to know that we have got complex number calculation facility in the Python programming. Again, one more important thing before we move on to the complex application is that let's say I've created out an account ID and that is simply 1233, and later on I decided that I want to convert it into some more precise value, more floating point number with the decimal precision. Now of course you can do that. Let's say I am having, let's just print it out first of all. Let's print out account ID and simply save it and run it. Nothing much fancy, just account ID being printed. But I can do that. I can print out in a floating format. So I can simply say float and I can use two brackets. That stands for the function. Nothing to be worried. Function will be covered up later on. But right now it's a quick syntax to follow up. And I can simply say account ID. What this float function is going to do, it will take up this account ID and it will convert it into a floating type of value. Again, let me just simply run that and you can see 1233.0. That's a good thing. That's a one thing. But again, if I want to take balance and want to convert into the integer, now here comes the caution. So although you are allowed to have the integer functions and pass on the balance out here. So I'll pass on the balance, that's save it. And when I run this, notice now it says 33. That means I have lost the .45 of my dollars. That's not a good thing for a banking application. So you should always be aware while converting the numbers from one to another, make sure that you follow the simple concept. If you're going to convert from low to high, that means from 33 to 33.45 or for some decimal number, it's okay because we are moving to the more precision value. That's okay. But from the more precision value, if you're coming downwards, that might create a little bit of problem. Now coming back onto the complex, although we have dozens of mathematical functions like absolute, the complex, the exponential, the floor, long, the log values, the power values, square root, and pretty much anything. And let's talk about a little bit about the complex. And those who got really scared of hearing me complex number, it's not that complicated. So don't just scare away and don't just run out of the room. That would only, I would say. Now let's coming back onto the complex number, how we can have a complex number. Printing out a complex number is really simple. You have got an inbuilt function that says simple complex. And you can put two brackets and pass on two values inside it. The 3, 4. Now those who are quite aware with the complex, The 3 is my iota part or the imaginary number. The 3 is the real one and the 4 is imaginary. If I save this and run this, the interpreter shows that it says 3 plus 4j, which is a correct syntax for having that. Now let me take that into a variable, a comp variable. Again, variables are pretty much powerful in the Python. They can hold up pretty much anything. Like in this case, they have hold up complex into just one variable comp. Now later on you will realize that the variables are so powerful they can hold entire source code of a one page into just one variable. But that's a sidebar. We'll talk about that later on. And you can access many properties of the comp by using a dot syntax, and I can simply say I want to access the real part of the imaginary number, and I would like to have a print statement before that. I'll save that and run this, and you can see 3.0, which is 3, is now a part of real. Let me just copy this so that we can have a couple of more things. And apart from the real, you can have the imaginary part. And you can also find a couple of other things. One of them which I know about that is conjugate. Now, how do I know that what of them are available and which of them are not available? Yes, simply I looked into the documentation, but I understand at first looking into the documentation is tough, so don't do that. Later on, I'll give you some opportunity to do that and I'll teach you how to do that as well. And when I run this, you can see the conjugate is actually really simple. It converts into the reverse of the iota. So 3 is my real, imaginary is this, and the final one in the line 17 is the conjugate. And of course, I could have printed out a message before them. It could have made the code really much more readable. But again, like in any language, the numbers are not that powerful, but that's not the case. We have got another function, we can import other libraries and all, but right now let's just keep the things simple because this is just an introductory lecture about the numbers in the Python. Let's move ahead.